Hey, grade 7s, this is Math 7, lesson 8.2. It's on perpendicular lines, page 305, number 1, 3, and 5. Question 1 says, which lines are perpendicular? How do you know? So remember, perpendicular lines will have a 90-degree angle. So one way that you could figure these questions out is to take your protractor, line the bottom line up on one of the lines so that it's with it, and if the line coming up from it is on this 90 degree, it is perpendicular. In this case, yes, it is. So A, it's yes, it's perpendicular. B, oh, nothing's going left and right, but if we rotate this, you'll notice that it lines up perfectly. So question 1B is also perpendicular. So yes, it is. This third one, it has a line that's going straight left and right horizontally, but this other line that's going through it, it does not go at a 90-degree angle. In fact, this degree angle looks like 60 degrees. This is 60 degrees. I'm actually kind of impressed. I drew this with a ruler, but I didn't use a protractor to draw it, which means that this here, if we go all the way around to this other side, that would be 180 degrees, the whole thing, which means that this section just here would be 120 degrees. This is not, it is not perpendicular, so no, it's not. How do we know? Well, these are 90-degree angles. Perpendicular lines will always be at 90-degree angle. Then we're doing question 3. Question 3 says to draw a line segment that is 10 centimeters long. So I took my ruler, started at 0 and went to 10. If you wanted, you could have started at 4 and gone to 14, because as you know, 4 to 14 is still that 10 centimeters. It's still that same length, because 14 subtract 4 is 10. You don't always have to line it up with 0. You could actually figure out a different way, as long as the difference between them is the measurement you want. And label it E to F. Part A says to use a ruler and a protractor, which is this thing. So if you have it, use it, to draw a line segment perpendicular to EF. So we want a perpendicular line to E and F. And to make sure that we're exactly right, here's one way you can do this. You take your protractor and you line up the 90-degree line with this line and draw an arc around. Then you flip it around the other way. Line it up with the 90 line. So the 90 line sits on line segment EF, and then you draw the semicircle around or near semicircle and make sure that the two lines cross. And now where those two cross, they are going to be perpendicular. So that's how you do it with a protractor. Just to mention, question 1 is out of 3. Question 2, you get a mark for drawing question 3, you get a mark for drawing EF, and it's 10 centimeters long. You get one for the perpendicular line, and you get one for each of the arcs. So 3A is out of 4. Question 3B says to use a ruler and a compass. So now instead of a protractor, we'll use our compass to draw a line segment perpendicular to EF. So we could label it like this, put our A there, and then we could just choose another point on here. You'll still get a mark for EF even if you're doing it multiple times. But instead of putting your line, your 90 line from your protractor, you're going to use your compass and you're going to draw a circle. And then you're going to lift it up, keep it the same size, don't adjust it. If it's moving, tighten it. And you're just going to choose any other spot on this line, and you're going to draw like this until these two circles or semicircles or arcs cross each other. And finally, draw a line through it. This is 90 degrees from that one. This one is as well. So part B, you get a mark for using EF. You get one for a perpendicular line that truly is 90 degrees. If we take our protractor, yes, it lines up perfectly with our 90 line. And you get a mark for each of these circles. So part B is out of 4 as well. Question C says check that the line segments you drew are perpendicular to EF. You're not going to get a mark for this, but to check, you simply use your protractor and measure it. Another way you could do it is from each of these points, you could measure what it is, and it better be the same on all of these measurements because it would be the radius of your protractor. So those are two ways you could check for C. And then question 5. So question 5 showed this here. And it said that your teacher would give you a large copy of this diagram. I'm sorry, I did not, but I'm sure you can see and measure in your book. It'll still be good. It says find as many pairs of perpendicular line segments as you can. So it's pairs, right? And how do you know they are perpendicular? Well, they'd have a 90-degree or a right angle. It would look like a corner of a room or that sort of thing. So we're going to find all the different perpendicular lines. Now, please note that perpendicular lines, they do not necessarily have to go through each other, kind of like these two cross over here. It could be two meeting at a corner that has a 90-degree angle, okay? Remember, I expect you to put the line segment names in alphabetical order and using the furthest ones. So this line segment would not be AB, it would be this whole thing here, which is AC. Not CA, not BA, it's AC because A comes before C in the alphabet. And this one here would be AE. So our first pair would be AC and AE. Put them in alphabetical order. So AC and AE. We'll also know that AE is perpendicular to FR. Right here, if we use our protractor, we'd be able to see that it's 90 degrees. So AE and FR. If possible, try to keep these in alphabetical order, like each set of them, but you don't have to do it that way. It's fine. Looking here, there are quite a few more in here. You'll notice FR and BR are perpendicular. So we'll say it's BR and FR. So that I don't accidentally do one more than once, every time I find one, I'm going to put a right angle on it. Right there, right there, right there. What about right here? We have KL and AE, so AE and KL. There's another one that's a right angle. KL and BR is also perpendicular. So BR and KL. I wasn't sure about this one, so I actually used my protractor, and 0 to 90, I lined up my 0 line with this line that is D to L. And then I noticed the DE actually is right on the 90 line. So right here, this angle here is a perpendicular line. So DE and DL. And there's one here. A to C and B to R are also perpendicular. There were 7 pairs of perpendicular line segments in that shape, so each pair gets 1 mark for 7 marks. So 7 plus 4 plus 4 plus 3 is 18. So this assignment's out of 18 marks. Look at that, an answer key under 10 minutes.